Hello students, here we are going to discuss about the lecture which is based on the introduction to manufacturing processes. So, I welcome you all. I Satyendra Upadhyaya, Assistant Professor Mechanical Engineering Department, Bundelkhand University, is going to explain about the manufacturing processes which we carry out to convert the raw material into final product. So, let us move on to the topic today. Before moving on to the final product, first of all we have to know about what is manufacturing. So, manufacturing is nothing but the conversion of a raw material into a finished good by applying various processes into it. Various processes which can be carried out with the help of hand, manual operations, with the help of machines, with the help of various tools and equipments. We used to convert the design, we used to convert the structure, size, etc., etc. So, manufacturing is, we can say, it is defined as the value addition to the raw material. Something we find it in a raw form, then we can apply some process to convert it into a finished part that will be treated as a manufacturing process. So, manufacturing basically a complex activity which involves all the equipments, machines, tools, etc., manual power. The knowledge of the material should be the basic requirement of the manufacturing process. So, basically it requires skills and knowledge of materials together. Application, after knowing the basic thing about the material, we used to apply the process. Sorry. Application of the process, and finally, after processing the material, we get the finished product. There is a some confusion about the production and manufacturing. There is always a difference between manufacturing and production. Production is the application of various manufacturing processes together to get the finished good, while the manufacturing is the technique, only a single process can be treated to convert the raw material into product. So, there is some difference which can categorize this manufacturing from production methods. Now, the product we can obtain after application of manufacturing must fulfill the requirements which is in the form of design, specifications, size, etc. Design, specification, and sizes. It also manufactured by the most economical environment economical environment, we can say we have to apply less capital income to get the raw material. Less capital income means no misery. Similarly, quality cannot be compromised. At any stage. At any stage. So, quality cannot be compromised means we do not compromise with the standards, with the specifications, the material, finishing, etc. Also, we can apply the newer techniques which are going to develop day by day. The modern era is going provide us the newer technology, newer skills, newer knowledge, advancement in the mechanical equipments as well. So, we have to adopt these techniques to convert the convert the raw material into finished part. So, adoption, next point is adoption of new technology in our part. Now, besides these factor, we hope from this raw material by applying some manufacturing process, we have to select the material. So, how we are going to select the material, which is the basic requirement for the manufacturing operation. So, materials which we are going to take for manufacturing processes. First one, various materials we have. So, out of these various materials we have ferrous metals. Ferrous metals are those material which composed of iron equipment, iron content as the main constituent. Iron content means the steels we are having, stainless steel, tool and die steel, various types of steel which mainly composed of iron content as a prime member. Second, besides this we have non-ferrous. We already understand from the first part that ferrous is the material which is having iron as a main content, while non-ferrous material where iron content is totally absent, right. So, materials which are under category of non-ferrous like aluminum, magnesium, nickel, copper, etc. Beyond these materials which do not have any iron content in them, we have some other materials which can also treated as the low melting temperature material, and they are not having any type of any single part of iron like zinc, tin and cobalt. These are the low melting material which is having very low temperature to melt down these. Third material is plastics, which is mainly used in today's era. So, plastics are the type where we replace the metals with the help of plastic. These are of three types, basically we all know. First one is thermosetting plastic, thermosettings. Beyond this we have thermoplastics, and third category of this plastic we have elastomers. Elastomers basically the category which completely possesses the elasticity in nature. So, simple elastic material we have the like rubber band, common example is rubber band, where it 100% regain its position as the externally load applied to deform the material will as it remove, then it regain its original position. So, elastomer is the category which comes under this category, but cannot be treated like plastic. While thermosetting plastic are those type of material which sets one time, which melts one time, molded into final product and cannot be treated with the heat again. While thermoplastics are the material which completely molded into final product with the help of heat, and after once it will be converted into final product, and when we apply it second time, third time, the heat will affect the finished product also. So, thermoplastic can be used again and again for the manufacturing part. Fourth category are the ceramics like grits, graphite, ग्रेट ग्रेफाइट, आपका सैंड etc. These are also the material, depending on their properties we can use them for various applications. Next one, the newer technology, the development in the technology will provide us the artificial means of materials, which provide us newer materials which is enhanced in properties. So, like composites. Composites are the materials which can be obtained with the help of artificial means by combining two or more materials together, maybe metal to metal, maybe metal to non-metal, maybe ceramic, plastic, maybe polymers. So, broad area of composite defined will provide us the application where we can use them for the purpose. Before moving on to the next part, various substitute metals also we have. Substitute materials, like conventional material we have iron, steel, plastics, various fields we have where we can replace these conventional material with the help of newer materials we have, like plastic replace the wood metals, composite materials replaces the metal or sheet metal. Then sheet metal is again replaced by plastics. So, various type of substitute metals we have where we can replace the conventional material with the help of newer materials. Next, we are going to define what is manufacturing categories. So, manufacturing is a vast field where basically we can say it involves 5 steps. First one is the forming, second one is casting. Moving on to the next step, we are having fabrication. Moving on to the next, welding, and the last step, which is not the least, machining. Machining operation. Beyond these 5 categories, we have one more category which can be recently introduced in the manufacturing field, known as rapid prototyping. This rapid prototyping can be heard with other name known as 3D printing, where we can obtain the prototype of a material and we can analyze that material, that whether the production method is applied onto it is good or not. Then we can change that material, where we can replace the material with the help of PVC, polyvinyl chloride we can use as a raw material for this purpose. 3D printing. Okay. So, one by one I am going to discuss all these 5 topics throughout the syllabus. This manufacturing is categorized into 5 broad categories. Out of these 5 categories, 2 are involved in volume 1 and next are involved in volume 2. So, here we are going to here we are studying volume 1, in which we have to study only the forming and casting operations. Forming is not a small area, it is a vast area which comprises of various processes. One by one we are going to discuss all these. It involves basically various operations, where forming is composed of forging operation, rolling operation, sheet metal working, extrusion, drawing, etc., and various miscellaneous operations are there. Casting is basically, with the word casting, basically we are assuming that sand casting is the main operation, but beyond this sand casting we have various other operations also, like investment casting, lost wax method, which is also known as by lost wax method, die and punch assembly, with the help of which we can use to sand casting, die casting, centrifugal casting, continuous casting, etc. Here, first of all, I would like to discuss with the forming operations. To continue with forming, we have to know about what it is. So, forming is nothing, it is defined as the requirement of the material to be changed into a desired shape and size by providing it with the help of some processes to be involved in it, like forging, I already told you, like rolling, where we used to reduce the amount of material in bulk. So, it is also known as bulk deformation processes. So, forming is nothing, but the definition of forming is to change the material into required shape and size with the help of certain processes. Basically, we can reduce these sizes, the shape of the material, by applying some effort with the help of external loads. So, for example, in general life we used to hammer the product to change its shape. For you already have done this process in your workshops. We have anvil, a metal part is placed onto it, and with the help of hammer we apply effort onto it. So, what it can do to this work material? It can compress this material. P, load is applied onto it. This material is reduces in its height while expands laterally. Okay. So, this is the dimension, original dimension, while after applying this load, this material will changes to this newer shape, where this is the dimension, expands in lateral direction as well as in front and back direction. Lateral means horizontally in both the axis, z axis as well as x axis, while in y direction it will compress the material to reduce the height. This reduction in the height is also known as upsetting of the material, right. So, upsetting is the position where we consider the reduction in the height, but we do not consider that the material which is in contact with the surface is applied any frictional portion to it. If some frictional forces which appears to the surfaces which is in contact with the work anvil as well as to the hammer surface, then it restricts the expansion of these edges to the lateral direction. So, this shape will be diverged in this manner. We will get this shape in this curvilinear portion, this, and hence the grain growth inside this material will be like this. This condition is known as barreling, where friction restricts the motion of the edges which is in contact with the surface on which it is placed and the surface by which it is striking. Is it okay? This is condition known as barreling. Later on I will explain it more. This is known as upsetting, where reduction in size, reduction in height is only taken into account. So, the forming can be done with the help of some processes, but for the forming, I would like to delete this part. For forming, the condition we are supposed to have in the material, that is the most important thing. We already studied about the elasticity and plasticity. So, the basic requirement for forming operation, the material should have plastic in nature. The plastic deformability should be there in the material. Only then we can treat it, only then we can convert that raw material into a desired shape and size. If the material having any elasticity, however, how much load we can apply it onto it, it cannot convert that material into final product, because after the removal of external load, the material regain its original structure every time. So, the material should follow the plastic condition. So, I am going to explain the what is elasticity and plasticity. You already have studied in your last semester that what it is. Already studied about the tensile diagram. Tensile diagram you heard about it, where stress and strain is applied. Epsilon in this direction, sigma in this direction. Sigma refers to the stress level, while epsilon refers to the strain level. Strain is what? Strain is nothing but the change in dimensions. Basically, dimension involves various categories such as the shape, the size, the volume, etc., etc. Stress is the pressure we are applying, and against that pressure the material is going to replicate, right, that is stress level. So, in first semester you already have studied about this stress and strain diagram, tensile diagram we can say, where we apply tensile stress onto the standard material which is taken as mild steel. For that standard material we have the structure like this. We have some points throughout this material, like first point, second point, third point, fourth point, and finally fifth point. Point number 1 refers to the elasticity, or we can say elastic point. Elastic point is that point which obeys the Hooke's law. Hooke's law suggests us that the stress level we are applying onto the material, against that stress level the material is going to strain, and as we remove the load, as we remove the stress, the material regain its original position 100%. No deformation should be appear here, right. So, elastic point is the first point through which this stress and strain are collinear to each other. Stress is directly proportional to strain, or we can say it follows the Hooke's law. Point number 2 is known as upper yield point. yielding. Now, in between these 2 points, we are continuously applying force, pressure. Against that pressure, the material is going to stress down, it is going to apply stress against that pressure, but deformation will occur after it crosses the point number 1. Here, it can suggest that the material cannot be regained 100% to its original dimensions after removal of applied load. Whatever the load we are applying, if it crosses the point number 1, it cannot be it can no more regain its 100% dimension, means some deformation will be there. Unfortunately, these points will deform the material, but as the requirement, as the desired requirement of the worker is not fulfilled, therefore, the material is not for our good purpose. Means material is regaining its position, not 100%, but some deformation will be there, only minor amount, minor deformation will be there, which is of no use. So, we are applying more deformation, we are applying more pressure to the material, then it crosses the, then it can go for the plastic condition. So, as applying stress level reaches this point number 2, means the deformation should be there. Deformation should be there means it can carry out for the regular purpose what we have to achieve, right. So, as the stress level crosses this point number 2, although the material is going to stress down, it lowers its stress level, but strain should be there. Strain continuously increasing, go on means the deformation dimension should be there. It can changing its dimension until and unless it will reach point number 3. Point number 3 is termed as lower yield point. Lower yield point is the point from where the internal structures, internal grains, the bonding between these grains should be there, which holds the material together in solid materials. The bonding between the materials after crossing point number 3 will going to break. As the bonding of these materials is breaking, means we are achieving our aim. Our aim is to go on into the plastic zone, plastic condition. So, this point number 3 will suggest us that the breaking will be there, means the strain level is going to increase upon removal of the stress level, or whether we are going to apply lower stress than the point number 2, it will continuously going on to increase the strain level, means deformation should be there, and as it crosses the point number 3, the breaking of bond will be there, and this breaking of bond suggests us that the material comes under plastic condition. It will never going to regain its 100% or minor amount of part it cannot regain, right. So, from point number 3 to point number 4, which is known as UTS, point number 4 known as UTS, ultimate tensile strength, the plastic condition is achieving, means we have to work out from point number 3 to point number 4 to achieve the final product, right. So, this is known as plasticity, and upon this only we have to work for getting the product. This is the main reason. After crossing point number 4 suggesting us that the maximum tensile it can sustain, the material can sustain is this point only, right. After crossing this point, the material will not be able to regain its position, although the stress level will be down, but it will going continuously for the fracture part. Point number 5, that is fracture means the material is going to fail now. After crossing point number 4, the material will no more be able to convert into the final product. So, this is the review about the previous class, previous part you have studied in your last semester. The revision of this should be hopefully done by you. The next lecture will be continue after this. in the next session about the forming operation in advance, right. So, thank you.